to Dr. Saliza. My name is Goo Jin Xuan. Now I'll present the Industrial Engineering Group project. For the introduction, the organization selected to identify problems related to the industrial engineering is the Noise and Vibration Lab in UTHM. The Noise and Vibration Laboratory established appetite, equipment, and laboratory facility to conduct research and consultant in noise and vibration problems for industrial as well as the public sector. The problem statement is there are absence of some equipment and facility in noise and vibration lab, and there are 30 students in an engineering laboratory class. The students need to queue and waiting in line to use the equipment and the facility to carry out their experiment. The student will waste a lot of time while waiting for the experiment. So the objective of this group project is to identify the optimal location for new equipment and facility, and to design a smooth experiment process flow by allowing the process for each group of the student to complete the allotted experiment within the event time, and to minimize the completing time for a group of experiment to process on 2 or more equipment. The scope of this project is the case study identified are focused in noise and vibration laboratory, and the industrial engineering concept as follows. Minisum model, line balancing, and Johnson rule are applied in improvement system. The optimal location of new steering gear simulator are identified by using the Minisum model, and the optimum process flow for vibration 40 simulation tests are analyzed by using line balancing. The completion time for 5 experimental run, impedance tube, universal vibration apparatus, reverberation room, vibration shaker, and digital full-thrust oscilloscope are identified by using Johnson rule. That's all for me. Thank you.
Good day, doctor. My name is Wong and my metric number is AD150240. I'm going to present for literature review. So first of all, what is industrial engineering? It is the branch of engineering that involves figuring out how to make or do things better. It is also emerged as a profession as a result of the Industrial Revolution. So what is the purpose for us to apply industrial engineering? It is to reduce the production cost, increasing the efficiency, improving the quality of products and services, ensuring workers' health and safety, protecting the environment, and last one is complying with government regulation. This is the table that summarized for the evolution of industrial engineering. There are 5 periods for the evolution of industrial engineering. The first one is 1750 to 1850. The main features for this period is division of labor, replacing muscles by machines, and concept of interchangeability. The second one is 1851 to 1930. The main features for this period is method of study, distinct identity of industrial or production engineering, use of electrical power, steel production, SQC and queuing theory, and followed by the period of 1931 to 1960. The main features for this period is ergonomics, quality management, and operation research. And then the second last period is 1961 to 2010. The main features for this period is automation, quality, supply chain management, lean and agile manufacturing, Six Sigma with base production, cloud computing, and manufacturing. And then the latest period is the main feature for 2010 onwards is Industrial 4.0, Internet of Things, IoT, sustainable manufacturing, big data and analytics, digital manufacturing. So the main contributors for all of the 5 periods are shown as in the most right column in the table. That's all from me. Thank you.
Good day, Dr. Saliza. My name is Pung Khang, and I'll present the methodology used in this project. The first methodology used in this project was the mini-sum model, where it is a technique to identify the optimal location for a new facility that have relationship to the previous facility. So by using the mini-sum model, the optimal location must satisfy the median and cost function. So there are three types of distance measure, where are the rectilinear distance, Euclidean distance, and flow path distance. So by using the mini-sum model, we are able to locate new facilities by minimizing weighted sum or of rectilinear distance from the new facilities to existing facilities or related to the new facilities. And then by using mini-sum, we're also able to identify the optimal location for new facilities x or y position that have activities relationship with current facilities P bracket A or B. Then the next methodology used in this project are the line balancing method. So the line balancing method is a method to design a smooth production by allotting processes to workers. So each worker will have complete the allotted workload within a given time. So the advantage by using line balancing is that we can promote one-piece flow and then avoid excessive workload, minimize the wastage, increase efficiency, and minimize the idle times. By using line balancing, we are able to design a smooth production flow by allotting processes to workers so as to allow each worker to complete the task given and workload within an even time. So, and then we are also able to increase the efficiency, productivity, potential increase in profits, and decrease in cost by reducing the time of each work task. Then the next methodology we use in this project are the Johnson's rule. The Johnson's rule minimizes completion time for a group of jobs. So given a schedule with a minimum max span on doing the task, assumption for this scheduling are in every case, the first experiment is conducted by a group of 1 and the second is group 2. Each machine is used by 2 groups of students. The time usage on each machine are different from different group of students. So this is a scenario of our project. And then by using the Johnson's rule, we are able to minimize the completion times for a group of jobs to be processed on two machines or 2 work at a time. So we are able to minimize the total idle time, results in a better customer service levels, and also simplicity and inherent fairness. So the addresses due date will be minimized, and the tardiness will also be minimized by using this Johnson rules method. So that's all for the methodology that we use. And the 3 methodology that used in this project are the mini-sum model, the line balancing, and Johnson rule to help to construct a better workflow and a better efficiency in the lab of noise and vibration lab UTHM. Thank you.
Good day, Dr. Salija. My name is Dui Dui. I'm from section 11. Now I'm representing my part, which is mini-sum model. Mini-sum model is a technique to identify the optimal location for new facility that have relation with current facility. Throughout the interview with Inkjet Zaroni, we know that he wants to buy a new machine, but the optimal location for the new machine is unknown. Therefore, we are here to help him in calculating the optimal location for the new machine. First of all, we'll draw a plot plan for the laboratory, and the plot plan is shown in the figure. Then the daily number of thread estimation within new machine and existing machine. The number of thread is estimated, and in our project there are 11 existing machine which is available, and the new machine is known as the steering gear simulator. There are 5 steps in calculating mini-sum model. Step 1 is calculate the median from given total number of trips. Step 2, arrange the coordinate S from lowest value to highest value. The step 3 is calculate the cumulative of WJ. Step 4 is compare the median value with cumulative value. Step 5 is repeat step 2 until step 4 for Y coordinate. For our project, we found that the median is 36, and step 2 we do arrange the S coordinate from lowest number, which is 2, to highest number, 6.5. Then we attempt the cumulative value. Then we found out that the optimal S coordinate for the new machine is located at 5. Then we continue calculate for the Y axis, which is we obtain the optimal coordinate for new machine is 8.5. Therefore, now I will proceed with discussion and suggestion for improvement. The location for new machine with steering gear simulator is found at 5 for S-axis and 8.5 for Y-axis. The steering gear simulator can be located in between microphone and predictive maintenance equipment. And we suggest to rearrange all the machine in optimal location by applying the MINISA model so that the laboratory can be in organized, safety, convenient, and good appearance. Besides, we also suggest that the old equipment must be changed to new technology so that the student can learn the new machine and then adapt in future when they are work. That's all for my part. Thank you.
Good day, my name is Seng. My metric number is AD150275. Today I'm going to discuss about the results and analysis. The method I use for this part is line balancing. The problems that I encountered during the visit for the lab noise and vibration is that some of the experiments used by their machines or equipment has too long procedures, which means too many steps. This contributes to too many idle time, and for a group of 5 to 6 members, it's very hard to distribute the task equally. Therefore, on my right hand side is a vibration fault simulation test process flow. It describes about all the steps for each process. Next, we have the summary of each steps for vibration fault simulation test for one of the mode vibration. For this experiment, it conducts 8 types of modes of vibration. So the task description is listed as follows, and the performance times is assumed with the reference on found online from Spectra Quest Incorporation. Next, we created a precedence diagram for one mode of vibration fault simulation test. Next, we calculate the cycle time. Cycle time for one mode of vibration is calculated as follows. For one day, we have 2 hours of lab, and for one lab session, we will conduct 5 experiments for 5 different groups. So for one mode of vibration, we use 24 minutes to divide by 8 modes, so we have 3 minutes per mode. Finally, we will use the original procedure to calculate the efficiency of it. So we have the original procedure efficiency of 53.7%. Next, we propose the new procedure, and combine the smaller steps, and the new efficiency is 80.6%. So we now at the conclusion, discussion and suggestion for improvement. The procedure efficiency has increased from 53.7% to 80.6%. This is because we combine the smaller step into a bigger one. So the lesser steps in an experiment will help the student to work faster, and each of the students will have an equal workload, because during the lab session, normally the procedures are not distributed equally because the tasks and the time is not carefully evaluated. So some of the members will have an easier part on the beginning of the stage, and the tougher part will be at the last stage. So it is not equal, as some of the easier parts will be done quickly and some of the tougher parts will take a lot of time. Thank you from my part.
My name is Koh Cheng Zhi, matrix number AD150266. Now I will explain the problem 3, which is the second rule for the student. This problem is occur when the student they are wait for a long time to do their experiment. So a Johnson rule technique will be applied to identify the completion time for two different groups of students when they are going to do 5 experiments. So after we apply the technique of Johnson rule, we can obtain a table which is include group 1 and group 2 when they are doing the experiment from machine 1 to last machine, their time usage. So after that, by arranging the lowest time, we can obtain the ADCBE, which is start from the lowest time until the highest usage of time, which is C. And then after that, we can obtain the completion time for each group respectively. And we can notice that the completion time for group 1 is 101 minutes, while from group 2 is 129 minutes. So the idle time for group 2 is 18 minutes. After that, we've made a discussion and suggestion for the improvement, which is the Johnson rule will help to manage the schedule for the student to minimize their completion time. And the second is the student just to wait for a few minutes to do their next experiment after the first group is settled their experiment. And the last one is filtration and overlap period will not be occur when they are doing the experiment. Thank you.
For the conclusion part, the optimal location for new steering gear simulator is 5 for coordinate X and 8.5 for coordinate Y. The efficiency of new vibration 40 simulation test procedure identified by line balancing is 80.6%, which increased 26.9% compared to the original procedure. The minimum total idle time calculated is 80 minutes, and the sequence of experiment process is ADCBE. The all problems stated by Noise and Vibration Laboratory Supervisor has been solved and improved by applying the industrial engineering concept, such as the Minnesota model, line balancing, and the Johnson rule. That's all for me. Thank you.